Now let's consider a slightly more complex argument. Consider this. Suppose we have the same opening premise as the previous example. If you give me one of your enchiladas, I'll give you a taco. Only as the second premise, you are giving me one of your enchiladas and you are giving me some guac. Therefore, I'll give you one of my tacos. So now you'll notice that in this argument, we don't have a straightforward case of modus ponens. Why is that? Well, if you notice here, we have the first premise that might serve for a modus ponens, but what we're missing is the antecedent on a line by itself. Or another way to put it is, we have the antecedent and the consequent, and what we want to get is the consequent as a conclusion, but we have an expression that isn't going to neatly fit as the antecedent. Why is that? Because the antecedent has only one thing in it, and that is the atomic proposition, you give me an enchilada. This doesn't match that, and so it isn't a case of modus ponens. A straightforward case of modus ponens would have the matching piece that we need, right? So the way we normally think about that is as a schema using variables. But here, as you can see, P is exactly repeated. This is the logical form. So the geometric figures contain something, and what they contain has to exactly match, or we don't have the logical form modus ponens. Okay, fair enough, but what we can look at is the logical form of that second premise. So let's analyze that. The logical form there is that we have something here and we have something here joined together by a conjunction. Now let's think about this proposition for a moment. Consider the proposition, you give me an enchilada and you give me guac. Now, if you think that through for a minute, you'll realize that there's only one situation in which that whole proposition can be true, and that is when this side is true and this side is true. Now, if you think about it, if both these sides are true, then any one of them has to be true. Or to put it another way that's a little more formal, if you have P and Q, then you can conclude P. So think about it. The same reasoning applies here. If you have a proposition joined to another proposition by a conjunction, then the only condition under which this whole statement is true is if both the two propositions on either side of the conjunction are true, in which case it's legitimate to conclude one side or the other side. So for instance, we can take P and Q and conclude Q. Let's test this out. We'll just do this for the first version of it with a short truth table. So P and Q, therefore P. So now we'll make our assumption. The assumption is that this is invalid. So if the conclusion is false, then P has to be false. If it's false there, it has to be false everywhere. Now consider, what would we make the value of Q? Could we make the value of Q, could we choose true or false in such a way to make this whole statement true? And the short answer is no. No matter what we pick for Q, because P is already false, it's going to mean this conjunction will turn out to be false. But that contradicts our assumption of invalidity, and so what that means is there is no set of values that will make the assumption true. In other words, the premise true and the conclusion false. So this argument is not invalid. And that's what entitles us to use this as one of our rules. But now, why did we take this detour? Like, why is this useful? If you think about it, it's useful because we can now take this argument and we can see a way to apply modus ponens by getting this second premise we need. And we get that second premise from the expression E and G. So now think about it. E and G is in exactly the right form for us to use this newly discovered rule. See, here's P and Q, and we can conclude the P part. So what that means is that if we have asserted E and G, we can conclude the E part. But now notice, if we can conclude the E part validly out of the second premise, then we have exactly what we need to use this original first premise in a modus ponens sort of way, because this E is now going to go there. So our original premise is E implies T. The E that we derive from the second premise using this new rule here, that goes in the second premise of modus ponens, and that allows us to conclude T. So if you look at this original argument and you think to yourself, okay, we have two different rules that we can apply. First, we'll apply this rule that we've discovered here that allow us to take one side or the other out of a conjunction, and that will give us the second premise of a modus ponens we need. So the first premise of the original argument is the premise of the modus ponens. The second premise of the modus ponens is what we derive from the second premise of the original argument. And the conclusion is just what we were after all along. So, in other words, the reason we could give for the validity of this original argument is that we can show that the conclusion, T, follows validly by applying two rules. This rule that we have newly discovered, which by the way is named simplification, so we can apply simplification to the second premise, and we can apply modus ponens to the first original premise plus the result of applying simplification to the second premise, and we get the conclusion that we were after all along. All right, so let's back up and look at this for a moment. The moral of the story here is that we are justifying the validity of an argument, this original argument, and we're justifying it by appealing to two argument forms that we are already embracing as valid argument forms and rules in our proof system. So again, the official word for that is axioms. We're adopting these two rules, simplification and modus ponens, as axioms that allow us to justify the validity of more complex arguments. So now, this obviously in front of you is a mess. And it would be very difficult to read and see exactly what the justification is for the validity of this argument. So the next step in our quest to learn how to construct proofs is we need to adopt some conventions about how to present a proof. In other words, the form that a proof should take. And it turns out that there's a very specific way we can write a proof that will allow us to be extremely clear about what steps we're taking, which rules we're invoking, and so on, so that that proof is readable and intelligible to other people. So that's coming up in the next tutorial.